Santorini's hidden fault lines are moving. Is it the next big eruption? That's the question keeping scientists awake at night. Beneath the iconic whitewashed cliffs, seismic alarms are registering tremors that echo the run-up to the cataclysm that vanished ancient cities and sent tsunamis racing across the Mediterranean. Right now, the very crust under Santorini is flexing as magma surges deep below, hinting at forces powerful enough to reshape continents. If you think the danger here ended with the myths of Atlantis, the truth is even more unsettling. Because what's stirring beneath Santorini could threaten not just Greece, but the world. So what makes this island so explosively different? And how much time do we really have before history repeats itself? Deep beneath Santorini's postcard-perfect cliffs, a slow collision is unfolding on a scale almost impossible to imagine. The African tectonic plate, dense and ancient, is pushing northward, sliding under the lighter Aegean plate in a process called subduction. This is not a gentle movement. The African plate plunges beneath the Aegean at an angle, dragging seawater and sediments down into the mantle. As these materials descend, they heat up and release water into the surrounding rock, changing its chemistry and lowering its melting point. The result is a wedge of mantle that begins to melt, producing magma that is far richer in water and gas than the magma found beneath most volcanoes. This volatile magma doesn't just sit quietly underground. It collects in chambers and reservoirs, sometimes just 3 to 5 kilometers below the surface. The presence of so much dissolved water and carbon dioxide inside the magma is what gives Santorini its reputation for violence. When pressure builds, these gases can flash to steam in an instant, turning a slow, creeping flow of molten rock into an explosive eruption that can tear apart the crust above. The exact geometry of this underground system is mapped by seismic waves and satellite measurements. Studies have revealed that Santorini's magma plumbing is not a simple vertical pipe. Instead, it's a tangled network of sills, dikes, and chambers, some shallow and some as deep as 13 kilometers. The main shallow reservoir sits directly beneath the caldera, but deeper down, a broad pool of partially molten rock connects Santorini to the nearby Colombo volcano. This mid-crustal zone acts as a kind of magma highway, channeling molten rock laterally as well as vertically. The angle at which the African plate dives beneath the Aegean is steep enough to generate intense friction and heat, but not so steep that it cuts off the supply of water-rich sediments. This balance creates a perfect storm for producing magma loaded with volatiles. Every pulse of magma that rises through the crust carries with it a fresh dose of gas and heat, priming the system for instability. At the surface, the evidence of this deep engine is everywhere. The ring-shaped caldera, the black sand beaches, even the hot springs bubbling in the sea, all are products of this relentless geologic process. But the real story is unfolding out of sight, where the plates grind, water seeps, and magma accumulates under growing pressure. Here, in the darkness miles below Santorini, the countdown to the next eruption begins, not with a bang, but with the silent, unstoppable movement of the Earth itself. Santorini's caldera isn't just a scenic marvel. It's a wound in the Earth that refuses to fully heal. The cliffs that ring the island are the jagged rim of a collapsed volcano, their layers stacked with ash, pumice, and shattered rock from eruptions that tore the island apart. These scars are more than ancient history. They are the surface expression of fractures that run deep into the crust, forming a latticework of faults that slice through the caldera and the seafloor beyond. Some of these faults trend southwest to northeast, perfectly aligned with the direction of the most recent seismic unrest and the hidden magma corridors revealed by modern imaging. Unlike the gentle lava flows of Hawaii, Santorini's eruptions are sudden and violent, driven by magma rich in gas and water. When pressure becomes too great, the magma doesn't always take the most direct route upward. Instead, it exploits weaknesses, old caldera walls, buried cracks, and the very faults that define the island's shape. These structures act as escape valves, guiding magma sideways as well as upward, sometimes bypassing the main volcanic center altogether. The legacy of these fractures is written in Santorini's recent past. Between 1925 and 1950, the island experienced a series of eruptions and groundbreaking events. The Camini Islands, now steaming in the middle of the caldera, grew from repeated explosions as magma forced its way through fractured rock. Each eruption followed a familiar pattern: months of small earthquakes, subtle swelling of the ground, and then a sudden breach as magma found a new path to the surface. The 1950 eruption was the last time molten rock broke through, but the fault lines have never stopped moving. Even in quiet years, satellite data and GPS reveal millimeter by millimeter shifts, evidence that the crust is still restless, still searching for a release. Underwater, the story is even more unsettling. Surveys and seismic profiles show that the caldera's faults continue beneath the sea, linking Santorini to the nearby Colombo volcano. These submerged fractures are not just relics of ancient eruptions, they are active pathways, capable of channeling magma, gas, and heat across kilometers of rock. The Camini, Colombo line in particular, forms a direct corridor between the two volcanic systems. When magma rises, it can exploit these weaknesses, sometimes triggering submarine landslides or even tsunamis if a flank collapses. Santorini's ring of faults is a double-edged sword. On one hand, they relieve stress, allowing the crust to flex and shift without catastrophic failure. On the other, they create ready-made routes for magma to surge toward the surface, bypassing natural barriers and undermining any sense of stability. Every fracture, every offset, is a reminder that the island's calm is only temporary. The next pulse of magma may find its way upward, not through the main vent, but along one of these hidden cracks, setting the stage for sudden unpredictable unrest. At 2:19 a.m. on January 24, 2025, seismic monitors across the Aegean registered the first in a wave of tremors that would soon shake Santorini from its sleep. By dawn, the ground had already rattled with more than 300 small earthquakes, enough to set car alarms blaring and windows rattling in fear. Over the next 6 weeks, the numbers grew relentless. Automated counters at the Greek Seismological Observatory ticked past 28,000 individual events by early March. The strongest, a magnitude 5.3 quake, cracked plaster and sent anxious residents into the streets. But it was the sheer frequency, sometimes dozens in a single hour, that kept nerves on edge and phones buzzing with alerts. Dr. Marius Iskin, a geophysicist with the GFZ Helmholtz Center in Potsdam, became the analytical voice of the crisis. His team's real-time data stream painted a picture of chaos beneath the surface. The swarm was not random, but organized, a migration of seismicity that traced a path from beneath Santorini's caldera northeast toward the submarine Colombo volcano. Each cluster of quakes mapped the advance of magma, fracturing rock and forcing open new pathways in the crust. The pattern was unmistakable, Dr. Iskin reported. We saw the earthquakes marching in sequence, kilometer by kilometer, as magma surged laterally through hidden faults. The swarm's epicenter shifted over days, first beneath the caldera, then migrating offshore, following the Camini, Colombo line. Seismicity at depths of 8 to 13 kilometers marked the initial pulse, but as the days passed, the action moved upward. By early February, the majority of quakes clustered between 4 and 6 kilometers below the sea floor, matching the depth of the main magma reservoirs identified in earlier surveys. Satellite radar and GPS stations registered several centimeters of uplift across the island, confirming that nearly 300 million cubic meters of magma had intruded into the shallow crust. Every new burst of earthquakes coincided with a fresh pulse of inflation, as if the island itself was breathing in time with the deep engine below. For the scientists, the data was both exhilarating and terrifying. Each spike in the count, each uptick in magnitude, carried the possibility of a breakthrough, an eruption that could arrive with little warning. The 2025 swarm was the largest and most intense sequence ever recorded in Santorini's modern history, far surpassing the seismicity that preceded the last eruption in 1950. The numbers told a story of a system under stress, its hidden faults acting as pressure valves for a restless, rising magma body. Dr. Iskin's daily briefings became essential, his calm delivery masking the urgency behind the numbers. "We are witnessing the crust fracture in real time," he explained. "The migration of seismicity is the signature of magma on the move. The question is whether it will find a way to the surface or stall beneath our feet." As the earthquake swarm grew, so did the sense of unease among the population. But for the scientists, the data storm was a window into the island's secret machinery, a rare chance to watch the countdown to a possible eruption play out, one tremor at a time. By the second week of tremors, the cracks in Santorini's calm were no longer just geological. At dawn, the main port at Athenios was already jammed with lines that snaked up the cliffside road, families clutching suitcases, hotel staff dragging carts piled with linens, elderly residents gripping their pets. Over 11,000 people would leave the island in less than a week, turning the evacuation into a test of nerves and logistics. Inside the chaos, hotel manager Andreas Papadakis watched his phone light up with messages faster than he could answer. The WhatsApp group that once traded jokes about minor shakes now pulsed with panic. By midnight, rumors of a government order to clear the caldera spread through every chat. Guests banged on his door, demanding answers. The official evacuation text arrived hours later, but by then, word of mouth and social media had already emptied half the rooms. It was like a dam breaking, Andreas recalled. One guest started packing, and suddenly the whole floor was in the hallway. The first ferries filled before sunrise. Each ship had a manifest that read like a cross-section of island life. Tourists clutching passports, local shopkeepers, construction crews, even a wedding party still in formal dress. The port's usual rhythm, built for a few thousand daily visitors, buckled under the weight. Ticket counters ran out of forms. Buses jammed the single road down to the docks. On the airport runway, charter flights queued wing to wing, but the terminal could only process a fraction of the crowd. A backlog of hundreds waited for hours in the parking lot, some sleeping on their bags, others refreshing airline apps for any sign of a seat off the island. Civil protection officials tried to keep order, but the system strained at every seam. The evacuation plan called for staggered departures, but fear moved faster than bureaucracy. WhatsApp chains became lifelines, hotel owners relaying updates about ferry schedules, warning of bottlenecks at the port, and passing along rumors about aftershocks and road closures. One message, "Colombo is waking up, get out now," spread so quickly that it crashed the group's server for an hour, leaving hundreds in the dark. For those left behind, the island felt hollow. Schools closed, restaurants shuttered, and the hum of daily life faded into the background noise of distant sirens and the low rumble of departing ships. In the villages above the caldera, grandparents gathered on balconies, watching columns of dust rise from the convoys below. Some refused to leave, clinging to the belief that the island had survived worse. Others packed family photos and heirlooms into cars and joined the slow procession toward the sea. The evacuation exposed more than just the island's vulnerability to nature. It revealed how quickly rumor, fear, and fractured communication could move people faster than any official order. In the end, the network that held Santorini together wasn't a government hotline or a disaster drill. It was a patchwork of phone calls, group chats, and word of mouth. When the ground shakes and the future is uncertain, people reach for each other, even as they're forced to scatter. In 2019, Dr. Paraskevi Nomiko and her team set out to map what no one had ever seen: the hidden architecture beneath Santorini's caldera. Using a combination of high-resolution marine seismic surveys and magnetotelluric imaging, they produced the first three-dimensional view of the island's magma system. What they discovered upended decades of assumptions. Instead of a single, isolated magma chamber, the data revealed a complex, branching network of reservoirs and conduits, stretching from just a few kilometers below the caldera down to a vast pool of partially molten rock at depths of 11 to 13 kilometers. These deep melts act as a central hub, feeding both Santorini and the nearby Colombo volcano through a system of dikes, vertical sheets of magma that can propagate at rates of 0.1 to 0.5 kilometers per day. The 2019 imaging showed that these dikes don't always move straight upward. They twist and fork, following fractures and faults that connect the caldera to the sea. During the 2025 crisis, new measurements confirmed the system's dynamism. GPS stations captured the island's surface inflating by several centimeters as magma surged into shallow chambers, while seismic waves traced the advance of molten rock along these hidden corridors. The real breakthrough was recognizing just how quickly the system can change. Magma can travel laterally between reservoirs, bypassing expected routes and creating new hazards in places once thought stable. For Dr. Nomiku, the lesson is stark. The true engine of Santorini's unrest lies not in what we see, but in the invisible, shifting labyrinth below our feet. A Santorini eruption on the scale of the Minoan disaster would not just threaten the Aegean, it would send shockwaves around the world. Models show that a VEI6 event here could launch more than 20 million tons of sulfur dioxide and ash into the stratosphere, enough to dim sunlight and cool global temperatures for years. The last time something like this happened, ancient cities vanished beneath falling ash, and the climate shifted across continents. Today, the stakes are even higher. Europe's airspace, among the busiest on the planet, would grind to a halt as ash clouds drifted across flight paths. The 2010 Eyjafjallajökull Eyjafjallajökull eruption in Iceland shut down air travel for a week. Santorini could keep planes grounded for months, with fine ash lingering at cruising altitude and drifting far beyond the Mediterranean. The fallout wouldn't end with empty airports. Crops across southern Europe and the Middle East would face weeks of darkness and acid rain, with models predicting harvest losses of up to 20% in the first year. The global food system, already stretched thin, could tip into crisis. Yet even with these risks, the world's ability to see disaster coming is full of holes. Most of the sensors that track earthquakes and magma movement are on land, leaving the submarine flanks of Santorini and Colombo in the dark. Climate modelers warn that without a dense network of seabed observatories, the next eruption could catch the world off guard, its warning signs muffled by miles of water and rock. In January 2025, more than 28,000 earthquakes shook Santorini, forcing over 11,000 people to evacuate. Scientific surveys in 2019 revealed a magma reservoir 11 to 13 kilometers beneath the island, with magma rising at rates up to half a kilometer per day. These numbers confirm that Santorini's fault lines are not dormant. They are shifting, just as they did before the catastrophic eruption that shaped the island 3,600 years ago. Yet despite advanced sensors and three-dimensional imaging, much remains uncertain. Experts cannot say exactly when the next eruption will happen or how much warning the world will have. What is clear is that Santorini's volcanic system is active, and the island sits atop a complex, poorly monitored network of faults and magma chambers. The risk extends beyond Greece. A major eruption here could disrupt global air travel and affect climate worldwide. As of today, the countdown continues, driven by evidence, not speculation.